Welcome. In this session, we'll talk about the impulse response, frequency response, and step response of a network or system. Let's start with, let's suppose we have a system or network. Input is x of t, and output is y of t. Okay. Now, impulse response of this system or network is defined as impulse response is simply the output when the input is delta function or impulse function. So if x of t is delta t, then the resultant output is referred as impulse response of this network or system. Okay, so impulse response is defined as the output when the input is delta t. Okay, now how do I determine the impulse response of a network from the transfer function? So if this network is represented by transfer function h of s, how do we determine impulse response from this? Okay, now we know in transform domain, output y of s is related to input by transfer function like this. Output is simply equal to input transfer multiplied by the transfer function. Okay, so what will be the output? H of s multiplied by the transform value of input. So our input in this case is delta t. So what is x of s? X of s is simply equal to 1. So 1 divided by this. So this is equal to h of s. So y of s is equal to h of s. So output of impulse response of a network is simply equal to the transfer function. Okay. In other words, to find the output of a network, that means the impulse response of this network, we simply find the inverse Laplace transform of transfer function. So y of t is simply inverse Laplace transform of h of s or y of s. Okay, and we know that's also referred sometimes by denoted by this symbol h of. So inverse Laplace transform of transfer function is simply defined as the impulse response of the network. Okay. Now, next we talk about the step response. What do we mean by step response? Step response is simply defined as output when the input is u of t. So if the input is u of t, then the resultant output y of t is called the step response of this network. Sometimes denoted by s of t. Okay. Sometimes we denote this by s of. So step response is defined as the output when the input is u of t. Now, how do we determine the output step response of a system when the input is u of t? So we know again in transfer function y of s is h of s multiplied by x of s. So h of s is given. And what is x of s per u of t? So x of t is u of t. We know the Laplace transform of u of t is 1 by s. So simply multiplying it by 1 by s will give you the step response. So multiplying transfer function by 1 by s will give us the step response of this network. Okay, but this is in transform domain. So to find it in time domain, we'll say y of t, which is sometimes called as s of t. Step responses denoted sometimes by this will be simply inverse Laplace transform of h of s divided by s. Okay, this is how we find the step response. And next is the frequency response. Frequency response of a network is the output when the input is sine wave. So if the input is, for example, sine wave is this, let me avoid phase term. So if input is this, then output is referred as the resultant output is referred as the frequency response of network, or even cosine wave. Okay, sine and cosine are one and the same thing. So if the input is sinusoidal, output is referred as frequency response of the network or system. Okay. Now to understand this, let's consider an example. Okay. Let's suppose we have an RL network. Let's consider an RL network. And suppose input is voltage, Vi of t. Resistance is R is 1 ohm. Inductance is 1 farad. To make the calculation simple, and output of this network is the current. Okay. And so you find the step response, frequency response, and impulse response of this network. So first of all, we have to find the transfer function of this network. So to find the transfer function, what we need to do, we need to draw the transformed version of this. Okay, so we'll write this in transform domain. So it will be Vi of S. R will be replaced by R, that is 1. L will be replaced by Ls. L is 1, so it will be replaced by S. I of t will replace now by I of S. So what will be the transfer function? H of S. H of S will be simply output is I of S, input is Vi of S. So this is the transfer function of this network. Now, if you use KVL in this network, the transfer function will be simply equal to 1 divided by S plus 1. That's an assignment. Please do that yourself. That's an assignment. Please find that yourself. If you use simply KVL, you'll be able to find this equation 1 divided by S plus 1. Okay, that's the transfer function of this network. Now, our goal is to actually find the impulse response, step response, and frequency response of this network. Okay, let's start with impulse response. Impulse response. Now, what do I mean by impulse response? If the input Vi of t is delta t, okay, then we have to find out. But let me take, instead of taking it delta t, let me take it 5 delta t. Okay, that means the magnitude is multiplied by r. This amplitude is multiplied by 5. So let's take it 5 delta. So what will be Vi of S? Vi of S will be simply equal to 5 times the Laplace transform of delta t is 1. That is equal to 5. So what will be our I of S from this expression? So I of S, which is equal to H of S multiplied by Vi of S. Output is transfer function multiplied by input. Now what's input here? 5. What is transfer function? 1 divided by S plus 1 multiplied by 5. So output in transform domain is 5 divided by S plus 1. So what will be I of t in time domain? Will be simply equal to inverse Laplace transform of this. If you take the inverse Laplace transform of this, is simply equal to e to the power of minus t u of t. So this is the impulse response of this RL network. Okay, where the input is 5 delta t. Okay, we have modified the delta function, just the amplitude is 5. Okay, now similarly to find the step response. So to find the step response, let's suppose Vi of t is a voltage, and that's equal to 10 u of t. So again, we have modified the amplitude of this unit step signal equal to 10. So what will be Vi of S? Vi of S will be simply equal to 10. What is the Laplace transform u of t? 1 by S. So input is in Laplace transform is 10 divided by S. So what will be the output? That is the current here. So output current will be equal to transfer function multiplied by input. Now transfer function is how much? 1 divided by s plus 1 multiplied by 10 into s. Now what we have 10 into s plus 1. This is the current in Laplace transform domain. Now our goal is to find this in time domain. So what we need to do here, we need to use the partial fraction expansion because we have two terms in the denominator. So what we'll do to find the inverse Laplace transform, we'll use partial fraction expansion. So we can write it as 10 into divided by s into s plus 1 can be written as a divided by s plus b divided by s plus 1. You know the procedure after this. In order to find a and b, multiply both sides by the denominator. This. So we'll be left with 10 is equal to a into s plus 1 plus b into s. In order to find a, we'll make this term equal to 0. For that, what we'll do, we'll put s equal to 0. So if I put s equal to 0, we'll get 10 is equal to a into 0 plus 1 plus 0 because b times 0 is 0. So a is simply equal to 10. Similarly, to find b, what we'll do, we'll make this term equal to 0. This term will be 0 and s is equal to minus 1. So if I put s equal to minus 1, so we'll get 10 is equal to 0 plus b into minus 1. So b will be simply equal to minus 10. So b is simply equal to minus 10. So substituting the value of a and b here, we'll get I of s. I of s is simply equal to 10 divided by s minus 10 divided by s plus 1. So we'll take 10 common. So it will be 1 divided by s minus s plus 1. So what is the I of t? I of t is the inverse Laplace transform of this function. So it will be 10 e to the power 1 by what is the Laplace transform of 1 by s? U of t. What is the Laplace transform of 1 by s plus 1? E to the power of minus t u of t. So if we take u of t common, we'll get 10, 1 minus e to the power of t u of t. So this is the step response of this RL circuit. Okay, this is the step response of this RL circuit. Similarly, to find the frequency response. So to find the frequency response of this network, let's suppose the input. Input is, I think, Vi of t. Input here is referred as Vi of t. Let's suppose Vi of t is 10 sine. How much? Let's suppose how much we'll take this. We'll take it t. Okay, 10 sine t. Okay, so our goal is to find output. Now output will be simply equal to output, that is I of s is transfer function multiplied by Vi of s. What is the transfer function here? This h of s is 1 plus 1 into the transform of input. Okay, what is the Vi of s here? We know that's equal to 10 divided by s square plus 1 square because omega is 1 here. So it will be 10 divided by s square plus 1 square. 1 square is 1. Now in the last session, we learned how to find the output when the input is a sine wave. We know if input is Vi of t is simply 10 sine t, output will be, that is I of t will be simply given as 10 a sine t plus phi, and our goal is to find a and phi. Our goal is to find a and phi. How do we find a? Where a is the magnitude of the transfer function. Transfer function is 1 divided by s plus 1 when s is equal to j omega. So what is omega here? Omega is 1. So it will be 1 divided by j plus 1 because omega is 1. So this will be 1 divided by under root of 1 square plus 1 square is under root of 2. Similarly, what will be phi? phi is the phase of transfer function 1 divided by s plus 1. When s is g omega, omega is 1, so it will be phase in 1 divided by g plus 1. That is same as 0, phase of numerator is 0 minus phase of denominator, that is 1 divided by 1, that's 1. That is minus 45 degrees. So substituting it here, we'll get the answer. So answer is 10. A is under root of 2, 1 by under root of 2 sine t minus 45 degrees. So this is the frequency response of this RL network. So this is the frequency response of this RL network. Okay. So our goal here was to find the RL network was given. Our goal was to find the step response, impulse response, and frequency response of the. First, we determined the transfer function. Now, I didn't determine that, which is an assignment to you guys, so you can do that yourself. Which is very simple. Using KVL, you will get this transfer function. And then we find the impulse response. When the input is 5 delta t, output is this in time domain. Similarly, if the input is 10 u of t, then the output, that is the first step response of this circuit, is this. Okay. And then we found the frequency response of this RL circuit. Frequency response simply means when the input is sine wave, and we didn't use directly use the Laplace transform or Laplace transform function here. Instead, we resorted to the method that we learned in the previous session. Right? If the input is sine wave, output will be simply only amplitude and phase is modified. We write the output something like, okay. Let me end this session here.